Welcome to my latest video, which is about Python, SQL, and SQLite used together to create your own personal data warehouse, which you can use for all kinds of data analysis. And you can see the ODBC icon there, and that's really to represent, that's kind of the hub of what's going to be going on here. My name's Brian Kafferkey. Really excited about this topic. It's something that I've been fermenting for a while to figure out the best way to present, but it's a really great idea. So please subscribe, like, share. I think hopefully you like my channel. I will warn you, it's a little more involved, so it's going to be not a quick 5-minute video, but I promise you it's going to be worth it because I'm going to teach you all about connecting to any relational database that supports ODBC, which is pretty much any database, as well as how to use SQLite in ways you may not have even realized you can use it. So let's jump in. And I do want to mention that I recently published a book available on Amazon called Master Azure Databricks. Azure Databricks in particular, is a passion of mine that I left Microsoft specifically so I could write this book. If you're not familiar with Databricks, we've all heard about big data, right? Big data is the big thing around the world. Well, Apache Spark is actually the most popular big data analytic platform on the planet. It's open source and it supports SQL, Python, R, Scala, and Java. So it's a very powerful platform. And Databricks is actually a company founded by the creators of Apache Spark that is a platform that leverages Spark and adds a lot of bells and whistles, but mostly it's a user-friendly wrapper around Apache Spark. And on Azure, it's like Databricks on steroids. You can do all kinds of great stuff. So that's what this book is about. It's a comprehensive resource, but more importantly, it will take you from beginner to expert. And that was really my goal when I started, because I didn't find any good materials that could do that. There's kind of all over the place, scattered different things, you know, streaming IoT and all these things, but not something that really took you from sort of zero to hero kind of thing. And that's what this book is about. It is step by step. So it kind of presumes, you know, assumes you're saying companies ask you to do something. Here's how you start. You start looking at data, you bring data in, and it provides you with data notebooks and things, which is the way you program on Databricks, and steps you through how to do each thing and guide you, so that by the end of this, through the use case, you'll know exactly what you need to do to use Databricks for pretty much any solution. The sort of pinnacle at the end is taking all this, creating features to go into a machine learning model used in predicting analytics, so predicting an outcome. Pretty cool. It's available on Amazon, so get it and let me know how you like it. And please, if you do get it, you like it, please do a review on Amazon. Let other people know that you like it. There is nothing out there. That's why I wrote this book. You may see other ones with Databricks in the titles, but trust me, they're very lightweight compared to this book especially. So where are we going in this topic? I want to start with the proposal, right? Not the movie. This proposal is all about why I think you want to use SQLite as a central repository to persist your data and create a sort of local data warehouse so that you can work while you're going. And by the way, I'm drinking out of my new mug, which is Azure based. And I don't know if you can see it, but I'm wearing my Python shirt, so I'm all branded as usual. But the idea here, I'll talk about why I think that's a great idea. Then I'm going to talk about the power and features of SQLite, which are not obvious. And that's why I want to walk through them, because you'd probably be amazed. I know I was. Then I'll talk about the local data warehouse architecture. In other words, I'm going to walk you through this, and I'll show you how to bring data down and how to do everything step by step. So stick around for that. But the first part, I want to give you a central picture. And limited time offer only. I'm providing a class to you, a Python class I wrote, specifically to use ODBC to connect to any relational database you want. I wrote it as a class so you can just say, these are the connection properties you need. And once you do, you can just call out and read any kind of SQL against it, and it will return the results as a Python data frame. So it's pretty cool, and we'll take a look at that as well. And then you're going to get to see my riveting end-to-end data warehouse load and exploratory data analysis. I'm going to use Jupyter Notebooks, but I'll give you the code. All of this is available on GitHub. I'm posting the link in the description so you can follow that and get all the code and everything. So again, this is going to be a really, if you're looking to understand how to leverage Python, how to do exploratory data analysis, especially if you already know SQL, but honestly, if you don't, you need to, because SQL is kind of very much a hub nowadays in doing data analytics, especially when you get into things like Spark and the bigger data platforms. So the proposal. Data analysis requires many transformations. If you've done a lot of work, I know I've been doing for decades now a lot of ETL work, bringing data in and building data warehouses. And typically it's done in Second bullet point, it's often done in layers, right? But here's the thing, the data is never in a simple place. Here's one file and everything you need is right there. Instead, you need to create columns. You need to join to data sources. You need to bring many tables sometimes together. You need to filter out places where you may have bad data or estimate values where there's maybe no values available. So there's a lot of things you need to do when you're doing this. And typically in an ETL, usually people bring in the data wherever it is, because it usually comes from many sources, and they put it into what's called a staging area. And those staging tables become the first layer. And then from there, they build like another layer. And oftentimes it's 3 or 4 layers of transitions of data before the data is actually in a format usable for the data warehouse. So you often create new columns for analysis. You can imagine something like, I have the quantity sold and I have the price, but I don't have the actual sales amount. Well, I could multiply the quantity by the price, and I could estimate or create the sales amount, which might be more useful. I also may need to do things that are useful for what's called model features. When you're going to create, say, a predictive model, you tell the idea is you want to know something like, what's a sales forecast? Or is this a fraudulent transaction? Or in this case, maybe I want to pick the most likely product somebody's going to buy based on demographics and things. Well, the input data, the columns you would use, are not typically just raw data. Here, here's their age, here's this. Usually you have to go through a sort of massaging and transformation process to create what are called model features. And one of the things, for instance, you might have heard of is something like one-hot encoding, or in R they call something factors. So factors take what is really a categorical variable and turn it into numeric. And one-hot encoding takes it a step further and turns it into like binary switches. So those transformations are even layered on top of other transformations you may have already done for analysis, and they're necessary to get your data ready for model training. Again, it's useful to have a place to put all this and store it in a more permanent way, because it can take you days, even weeks, to sort of layer through this. And you may repeat certain stages until you feel like, okay, that's clean enough. Now I can work on transformations, and now I can do this. So it's very iterative. So the idea, also something you may want to do, is stratify the data. And I'm thinking in particular, something I saw, for instance, in the data I'm using in this use case, which is sales data, is that you might want to predict what product someone's going to buy. Well, it turns out that there's one popular product, and that product sells about 75% of the time. Now, predictive models generally will say, oh, well, it's 75% predictability is pretty good. I'm just going to always pick that product because it appears so often. So to avoid this data skewing problem, you typically will resample the data and distribute it in a way that makes it look more random and less skewed towards one thing. In other words, you'll have it create a new data set that shows each model of being sold as roughly the same amount of sales. By doing that, you avoid this whole skewing in which it just picks the most likely, because the fact that one thing is picked the most often isn't really something you want to be using to predict the outcome. You want to be using things like, what are the correlation, the things that correlate to that, like maybe the person's age, maybe the person's distance, if they're riding a bike in this case, maybe how far is their commuting distance to work. If it's short enough, maybe they ride a bike. So these things might be the things you want to use. And in order to avoid this default adoption by your model to go with skewed data, you might have to actually resample and redistribute your data. All right. The idea here is that as you do all this, instead of just writing out flat files, which is the alternative approach, I guess, and just having lots of either CSVs or some other format that you're writing out and pulling back in, because you're going to need this over and over again, you can persist it in a database. And by doing that, it's a lot easier to step in from day to day and build off of what you've already built. You've got saved results. Next day, come in and build off of that until you have the final outcome you want. And you could even take the layers that you've created and automate that as a sort of ETL process for your data warehouse. And now you just run your pipeline, they call that. So you just run a pipeline and you've got an ETL process that will get your data. But the idea is you're not always going back, recreating the same things to get where you left off. And you're not going to get confused because of all these different files you've created all over the place. And that's really the concept behind this. And I think it's a really good one. And I'd be interested to see how people do when they use this. So the idea is going to have like your own little local data warehouse. Now you may not use dimensional modeling, which is the sort of Kimball method of creating data warehouses where you separate dimensions and facts. We'll use sort of pseudo ones. The example I'm going to use isn't a true data warehouse in that sense either, but this can be extract files. It can be anything you like, but the idea is really more that it's yours and you're going to be using it to persist data. And I'll show you with a step-by-step notebook that you can download and trade with your friends and use to see this. So before I jump into my riveting demo, I want to step through a little bit about the power of SQLite, because it's really easy to underestimate just how much SQLite can do. I was surprised to learn that you can have up to 281 terabytes in a SQLite database. That's something that, when I started with databases, even the most powerful databases didn't support that much. Granted, that was a while ago, but 281 terabytes is a lot. And if you're doing that much, you shouldn't be using your own PC in the first place. You're probably leaning towards a big data platform like Spark, by my book. Anyway, so we can do that. You can have up to 2 billion tables in a database. And this is not as impressive a number, but 64 joins in a query. That's important because, honestly, if you get above a dozen joins, I usually typically will have maybe 6 to 8 joins in a more complex query. You do want to minimize this because it gets unwieldy. You can always take things and extract it to another table and then do more work with it, but 64 is actually plenty. Now, the maximum size of a query here is 187 megabytes, right? 107 megabytes, something like that. Obviously, that's one big string, and that's what we're talking about. You're putting a quote string in, passing a SQL query. I would hope you never come near that, but that just gives you an idea. You're not going to find too verbose a query that you can't run. What about SQLite features? Well, the first thing to remember about SQLite is no configuration. That's the promise from the SQLite website. Just use it. It's built into Python. So in other words, if you've got Python installed, even just the out-of-the-box installation, you have SQLite integrated. It's called PySQLite, I believe. So actually, you just import the SQLite library. We'll see that, and you can now use it. So you've got SQLite built in. You've got the API from Python to SQLite, and it integrates with pandas. So we've got some really good stuff here. The footprint of SQLite, despite its power, is only 600 kilobytes. Now, I was trying to figure this out, like how does that compare to, say, something like SQL Server Express? SQL Server Express, and even the new SQL Server Edge that I've seen, touted at the last Ignite conference and things, is 1 gigabyte minimum recommended. I think they said something like 600 megabytes minimal, and you can go up to like a gig or more. And if you want to add some of the extensions, then it's going to go above a gigabyte. So we're talking about 20 times as much memory required for those other databases, which are also supposed to be light. So this is good because obviously you're working with a lot of data. You want to bring things into memory in the form of data frames. You don't want to be consuming a lot of memory on your database. SQLite is the most popular mobile database on the planet, so it's used for all kinds of mobile applications, can run in your phone, can run anywhere. So obviously it can't take up too much memory or you're going to run into trouble. You have support for views, triggers, and even window functions. So all the typical SQL things you think of, select statements and filters, that's all there. But it's important to realize you can create, for instance, to simplify your access to data, you can create views, which are really queries, but you treat them like tables, and it will run the code on the back end to get the data together. So you can have joins and things. Triggers are really usually more of a transactional thing, but basically a trigger is something where you insert or update a row in a table, and you'll fire off some action to do something else. And window functions are really good. They're very powerful for any kind of analytics because they let you do groups within groups and even independent groups. You're running one thing that's a summary, but you can do external kind of summaries and actions that are outside of that. So that ability to use window functions is a really nice feature as well. Another thing is, if you're using flat files and you want to only access subsets of the flat file, you're going to be stuck either loading the entire thing in, and if you want to filter it, you're going to have to read the entire file because there's no way for the operating system to know where your rows are. But because SQLite supports indexes, you can add indexes to your data, and there's different types of indexes, even partial indexes, clustered indexes, and all that, which gives you a lot more options for efficiency. So if you're accessing certain tables a certain way, you can add indexes to it and get a lot better performance, especially if you only want subsets of a large table. You can keep it all, but then just say, I only want this year or this month of data. It has full ACID support. ACID means really transactions, so add, change, insert, and delete, and the ability to do commits and rollbacks and things like that. Now, you probably won't need that in your typical data analysis. That's really more for transactional systems, but you may find an opportunity where that comes in handy, so I wanted to bring that up. It also has something interesting called in-memory databases. So if you don't want to actually create a database on a physical file on your system, you can just build it in memory or persist your data warehouse as a physical database on your drive, but load it into memory when you want to use it as a way to make it perform a lot faster. So some really nice options. And best of all, maybe of all of this is, maybe you're thinking, well, I have a commercial product. I'd like to be able to just give this thing out to my friends or sell it for money. And the license is no license, really. This is considered public domain. In other words, it's given for free. Do what you want with it. That's what the SQLite website says. So you don't have to worry about any licensing. You can give this to people freely. You can use it. You can build it into products. And SQLite is okay with that. So it's pretty cool features. And remember, the nice thing here also, because of all this, you can just hand someone your SQLite flat file, because that's all it is, just stored in a file. And as long as they have Python or any SQLite access, they can read and write to it. So it's all free. And SQLite runs on every platform. So you pretty much, doesn't matter what they're using, Mac, Android, Windows, Linux, it doesn't matter. So you have instant data warehouse. Let me walk through what I propose to do in my demonstration here. Let's assume you work for a company. Now I'm using the AdventureWorks dataset from Microsoft, which is used a lot because it's a pretty complicated, complex set of relationships within a database, and they provide a data warehouse version as well as a transactional system, but it's all fictitious, which is great. And AdventureWorks is a sporting good company that makes, among other things, bikes, and bikes is really most of what they sell. They have a internet sales side as well as stores and physical stores. So imagine you work for AdventureWorks and your management has asked you to do some analysis. Maybe they want to see visualizations, predictive models, and things around their data. Well, you see, okay, most of their data seems to be in SQL Server, but oh, wait, there's another system, maybe CRM or something, that's actually in Postgres. Now imagine this could also be Oracle or MySQL or any number of other databases. The method we're going to use to read these is ODBC, so you can read anything as long as you can get the right driver to go with it, which are pretty well available. We're going to put the data into a SQLite local database, in other words, on our own machine. And as we go along, we may also find, wait a minute, there's vendors and outside people to the company, customers, etc., that give us data. And this happens all the time, right? You get invoice files that you bring in, and maybe they're in the form of CSVs or JSON or XML. So you're going to bring those in, and it's very common you want to bring those and match that up and merge it in with your data. So again, this is a pretty typical situation when you're trying to do analysis. You need to bring data from a number of different sources. They're not all in one database and they're not all in one platform. And the nice thing is, it's not hard to do. We'll be using Python, pandas, SQLite, which are pretty much standard packages, and PyODBC, which if you don't have it installed, if you install Anaconda, you'll have all of this, which is what I always recommend. But if you don't, you can just do pip install. Now a quick thing you can do is if I go here and say CMD with the folders I want to work in, it'll bring me right to that folder, which is a handy thing to do. From here I want to get into Jupyter Notebooks. I created a little batch file to simplify this. I want to run Jupyter Notebooks. I have a video also on using Jupyter Notebooks, so if you're not sure how to do that, take a look at that. And I'm going to go into the notebook folder in here. And I want to call your attention to this notebook. Now before I do, I neglected to talk about something else, so let me do this as well. What I wanted to show you was I wrote a class, I mentioned I did this, and I put it into a Python package for you. So you can just go in and use it. I do put some warnings here, using this at your own risk, etc. I don't want to be responsible for any problems that occur if you run into any with this. So make sure you're being secure, test your code, etc. But this is really meant to demonstrate anyway. It's just for demo purposes. But what I'm doing here is I'm bringing in PyODBC, right? Pandas and SQLite 3, that's the first thing. And I'm creating a class, right? SQLDB. And I have to initialize it. The only reason I'm using a class as opposed to a straight function is I want to persist certain properties about the database I'm connecting to. By doing that, I can just declare an object instance, tell it where the data is, etc., and now I can just keep calling out to it and running queries. I'm making an assumption here too that I don't want to hold the connection open to the database. Generally speaking, DBAs will tell you, and I would say, try to get what you need from a database and get out as quickly as you can. You don't want to hold open connections. It's resources, it's memory, and especially depending on the criticality of that database, it's a bad idea. So you'll see in here, we actually just get in and get what we want, and we don't hold any connections open. When this is called a constructor, and in Python this is an initializing thing, when I create an instance of this class, it will automatically run this initializing or init function. So that's the constructor. Now it takes a bunch of parameters like server, integrated security. I'm going to walk through these. But what I've done is, just in case, I put in defaults. If you're working with local SQL Server, for instance, usually you can just go with, in parentheses, local, and that means the local database instance. This integrated security is a feature available, really, as far as I know, only on SQL Server, but it means that Windows has already validated who you are, you're authenticated, and when you go to the database, it automatically says, do you have access or not to various tables and resources. Really nice thing to have, because now I don't have to show credentials and expose it in code, and obviously nobody can get in unless they've already authenticated as me. The other thing is a driver. So this driver is specific to SQL Server, but on the constructor, in other words, when I create my class, I could change the driver to go to Oracle or Postgres, as you'll see, etc. So I can make that whatever I want. And I have the database name, so this is just going to be what database do I want to start at. And finally, if I'm not using integrated security, so if this is changed, it's overridden to be false, then you want to make sure you give the username and password. So I just put dummies in there, but you would pass in the actual username and password. So when that runs, what I'm doing is creating a bunch of variables that are part now of the class or the object. So this object instance will take the server name you pass in and store that as an object instance variable. The setting for integrated security, true or false. The driver, the database name, and if you assign them username and password, otherwise it will have the defaults. The other thing it does is it's going to create a connection string. When you connect to a database using ODBC, it actually has this thing called a connection string, which are all the properties it needs to get to the database. So here it's saying, the driver, the server, etc. And if I go to the right here, I kind of let it string over. Should probably have wrapped that. But you can see here, I've got format SQL driver, and so this is formatting. It's putting in the driver, etc. and the database name. So it's putting all these pieces I need in place in order to connect. Now, it says here, if not integrated security, and maybe this isn't, people can always criticize, this may not be the ideal way to code something, but if it's not integrated security, then you're going to need the user ID and password. So what it does is it appends those on, so it'll have that information. Otherwise, it doesn't need it because you've already been authenticated on Windows. Again, that's a Windows-specific thing. I don't know how it'll work on Linux. I assume if you don't use integrated security and provide user ID and password on Linux, you should be okay. Let me know if it doesn't work out that way, and it'll be good to know. Also, so now we have one method, and one method only to this class, which is called getDBData. And other than self, which all methods of a class have to have, it has a SQL statement. You're going to pass a SQL statement to it. I create a connection object using PyODBC connect, and I pass in the connection string. So this is going to connect me to my database. Then, remember, you are passing in a SQL statement, right, up here. And now we're going to run it. So we're going to pass the SQL statement here, pass in the connection string, and notice I'm using pd.readSQL. This is a pandas function, not SQLite and not ODBC or anything like that. The reason I'm using pandas is because this function, not only will it run against my connection, but it returns the results as a data frame. If I don't do that, and if I use the default ODBC, I'll end up getting a list back, which is harder to work with. It's certainly not great for sorting and grouping, etc. So I'm going to just use read SQL. I get back the result as a data frame. I close my connection, and I return the result. The end result is, first I create my class, and let's say I'm going to the AdventureWorks authenticated, let's say Windows authenticated security, so I don't have to, I'm setting true, I'm leaving that. I don't give it a user ID, I don't give it a password. I connect. Once those properties are set, I can now just keep calling get DB data on that object and just pass in my query, and I'm done. So that's the idea here. I could create another object instance in which I use Windows security, SQL Server security, where I do need user ID and password. Or I could create a connection overriding other properties like the driver and say I want to go to Postgres, and here's my user ID and password, or Oracle, or MySQL. So this is a very flexible and easy to use class that does a lot of work for you. And I love myself, what I really love is the read SQL statement returns a data frame, which is really good for data analysis. All right, so that gets us to sort of the bare bones. Now let's go back to our story here. And I'm going back to my notebook. I'm going to open Python SQLite DW. That's the big notebook we want to use here. And you can see here, it's kind of got some information here. If I want information, this link will give you on SQLite 3. First thing I need to do is I want to import the SQLite library, and I'm just going to print out the versions. Now, if you're not familiar with using Jupyter Notebooks, you can use commands up here to run things like the run command. I'm going to use Shift-Enter to run the cell that I'm in. This is a code cell, right? The ones that just have comments like load the SQL package, those are called Markdown. I have a video on that, so you can learn about those if you want more. But I'm just going to run this block, and it gives me the versions. And it's just really, I like to print the versions really just to confirm it loaded correctly. Now what I want to do is I want to connect to a SQLite database. So I'm not going after the ultimate databases I want to pull data from. I'm creating a local database in SQLite. So I'm using SQLite 3, saying connect. And then I pass in the name of my database, which is really just the name of the file I want to use without an extension. So AW_EDA is the name of it, and it's going to automatically create that file if it doesn't exist. But if it does exist, it will find it and connect to it. And that's going to be in the current directory where I'm sitting when I came into the notebook. So I'm going to run that as Shift-Enter, and I'll print out this SL connection. Just shows me it's an object. Another thing, in order to submit SQL statements to the database, I need to open up what's called a cursor. You can think of the cursor as kind of like a little command window that allows me to send instructions to the database. So I'm going to run this statement, cursor equal slcon.cursor, and that will allow me to do it. So I'm using the connection object I created and grabbing a cursor. If I display it, it just shows it's an object. Okay. Now let's take a look at our AdventureWorks data. So we're going to be bringing in data from the AdventureWorks database. I can't really provide that to you. So if you want to really do this for yourself and pull data down from AdventureWorks, you can go out and do a Google search and just search for the SQL Server version you're using. So if you're looking like SQL Server 2017 AdventureWorks, you'll find it, and they'll have all different versions and sizes, and you can pick what you want. There is an OLTP, the transactional database. I'm only using the one that's for the data warehouse, so it's one that's AdventureWorks DW, I think it's in the name. And I'm only using a few of the tables there. So I'll include some CSV files that you can also use and just put in some database if you want to simulate some of this. But if you really want to go through and experiment with AdventureWorks, go ahead and install and run that. You won't be able to do necessarily all of this because obviously another piece I'm going to be pulling down is from Postgres because I want to demonstrate doing that. So not all of this may be completely usable to you. You may have to do some work. Nonetheless, if you modify this to your circumstances with SQL Server, etc., you should be able to get everything working, which is really what my goal is here. So let's look at the AdventureWorks database. We can see in the middle at the hub is something called a table called Fact Internet Sales. So this is metrics. This is the sales amount. And even though they don't say it, there's actually some dimension attributes as well in here. But it's basically the sales information, which is how many units were sold, who bought them, pointers to the customer, etc., so for the related information on dim customer, and the amount, etc. And you notice that, as I mentioned, there's a key there that will bring you to the customer table, which has all the details about the customer. There's also a sales territory key, and by going to dim sales territory, you can get the related information there. Now the product, this is what's called snowflaking in a dimensional modeling technique, because notice that product, first you have to go to the product, then to get the category, subcategory for a product, you have to join and go to dim product subcategory. Then if you want the category, you have to go from that subcategory to the dim product category. So 3 tables all have to be joined just to get product information. This would be a really bad design, I think, in a dimensional warehouse. You wouldn't normally do this. You would actually just take those 3, put them together into one dimension and join to it. Especially as you'll see, not even that many columns or rows, so it really is a bad design. But we'll see this. The other thing you'll notice is something called dim date. Date dimensions are really useful. If you've never used them, if you learn nothing else, go create one, download them. There's a lot available for free. What they do is they allow you to take something like, you typically say I have a sales date, and people always want to report on sales date, right? So you say people want to see by quarter, by month, what day of the week was our best sales. Well, rather than parsing through a date, you can just take the date, join it to a table in which that's the key, the date itself, and that will automatically have attributes like what quarter does that fall into, what's the day of the week, etc. And it really is nice for being able to roll up and summarize data by those attributes. So this is the general layout of the data we're going to go to. And let's jump in here. So what I'm going to do here, the package I'm giving you is in a folder, right, called dbutils. And underneath it is a class called dbaccess. And I'm going to be importing SQLDB from that. That's the class that's inside that module. Okay. And now I'm just going to put my, I happen to have a kind of a weird SQL Server name. It's the name of my desktop, etc. from my database. I'm just going to put that in a variable, so it makes it a little bit easier to call it in. And the idea here is I've already created in the previous reference in SQLite a local database, and that's going to hold the data. So now I want to reach out to these different other databases. One is SQL Server, to pull data in. So let's take a look at using it. SQLDB, when I create an instance, I'm going to say I'm going to create a new object. I'm calling my class within that file I just imported, SQLDB, and this is actually going to call that init function I showed you. That's the constructor. I'm giving it the server name. I'm telling it that it is in fact using integrated security, which means I won't need to give it a user ID and password. I give it the connection string, and these connection strings are available online. You just Google and say SQL Server connection string ODBC and you'll find them. And then you'll see what's the name of the database. So this one is AdventureWorks DW 2017. And when I ran that, this object is now instantiated and it's pointing to my SQL Server instance I just showed you. All I have to do now is call the getDBData method and pass in a SQL query. So in this case, I'm just going to demonstrate, I'm going to display a couple of rows of dim product. You can see here. Now because it's a data frame, notice it looks pretty good here. It's not just a list. It even gives us some extra information. Notice I can say top 2. That is syntax. That's T-SQL. That's Microsoft SQL code syntax, not generic SQL. So when you're using ODBC, you can actually pass the SQL through that is relevant to that database. So I'm going to do this again, only this time I'm going to assign the return value to this data frame, and then I'm going to display a few rows using the head function of the data frame. But again, I'm just saying this time get 5 rows out of dim product. If I run this, you can see it did that. So I hope you can get the idea. This is kind of cool because I can really easily now just do queries against SQL Server and get data frames back. And I mean, look how easy this is. It's a single line and I just pass in the SQL statement. It may be a bit long names for you, but I like things to be clear. So this name, AW SQL, tells me it's AdventureWorks SQL Server. IS means integrated security, so I can keep track of what I'm doing. All right, let's take another look. This time I want to use SQL security. So now notice I named it the same, but this instead of IS is now saying SQLsec, SQL security, meaning I need to give it my very hard to guess names for user ID and password. And I'm doing a lot of stuff, so I'm passing in, for instance, also, again, the driver. I could let it default, but I didn't. What database? Again, I have some defaults in there. I'm going to just override the whole thing, but I don't have to. The only thing I really need to do is this part and this part, because those need to be specified. And now let's see if I can use, again, notice this is a different object. So I can now use two different objects to query against the database. And I'll run this. And you can see now I got 2 rows out. And I'm only bringing 2 back. Head 3 is kind of irrelevant, but you get the idea. Okay, great. What about other databases? What if I mentioned Postgres? Well, I'm going to create an object here. I'm going to use the same thing, SQLDB. I'm calling it localhost because that's okay for the default on my system for Postgres. I'm saying I don't have integrated security. I'm using, this is the driver information I need for Postgres. And you can see the database name is development, and that's my user ID and password. So that's about it. I should be able to run that. And then I'm going to do a quick query. There's a table available on this Postgres database called dim customer. And you can see that worked too. So the big takeaway here is I can query any database I want. I'm using ODBC. The details of that are hidden from me. I don't have to worry about that. Now I could have done this, and I thought about doing this as like another notebook I could just call and it would define functions or even my class. But I love the idea of it being a package because now you can just copy that subfolder and put it wherever you want it and use that code if you want. But again, test it, make sure it does what you want. All right, now that we know what we're trying to do, let's start to look at what the value is for this proposition. So let's start by saying, I want to get total sales by category, subcategory, and product name. So this query is a fairly complicated query, right? I'm going to be pulling some information from fact internet sales, dim product, and I'm going to join the dim product to the, from fact internet sales, to my product. And then I have to join from my product to the subcategory, and then I have to go from the subcategory to the category. It's kind of a lot of layers, but I need all of the information to be really relevant because I'm kind of more interested really in the subcategories than specific products. Notice I can aggregate. Now the cool part of this is I'm not bringing it down first to do this. I'm not going to just bring down like a billion rows and then say, let's query it locally. SQL Server is pretty powerful. Make it do the work. So let's save this SQL statement as, and notice you generally when you're doing these queries use triple quotes, especially when it's a multi-line you have to. But now I'm going to be able to run my SQL Server security version of the object, and I just pass that statement in and I run it and I get a nice little summary, and notice it displays little ... to show you it goes on a lot of rows, not showing everything. But now I have an aggregation that was done on SQL Server. I made SQL Server do the work and just give me the results back. And I could easily, just as easily, have summarized at a higher level and made SQL Server do even more work. Now this time I'm going to take the data frame I created, which is sales summary DF, right? And I can use, this is a cool statement. This is awesome actually, because I'm going to use ToSQL, which says take that data frame and actually save it as a table in a database. I think that's really cool and it's powerful because honestly, I see a lot of videos out there and people are like, here's a SQL create statement and doing inserts, and I'm too lazy. And you should be. Like, you want to do things the most efficient way possible. That's what being a programmer is all about. Here I can just say ToSQL. I'm giving it the name in the database, and I'm pointing it to my SQLite database. And I can even say, if it exists, replace it. Now, there's a few options, and I wanted to put there. You can say replace, append, or fail. I think it's error, fail. I have that listed later. But I'm going to say replace. So in other words, I'm going to run this statement, and it's automatically going to create that table for me. All right. We'll play around with that. But let's take a look at this data frame. Another thing you can do is you can query. Now, I'm always forgetting the names of the name of columns in my tables. What are the object types? Like, is the column an integer? Is it a decimal? So I'm always kind of refreshing it. That's why I like to keep like SQL Server Management Studio around. But I can do that also off the data frame. So if I do data frame name.columns, a quick way to get my column names, and those will be exactly the same in the table I just saved. If I want a little more like the data types, I'll get some help. If you see object, it generally means it's a string. If it's a date or something, you should see it telling you what it is. So that's pretty good. And I can also do this thing called a pragma. So using the read SQL query of pandas, I can run this statement, import pandas as PD. I'm surprised after all these statements I didn't even import pandas yet. But you can see here now I can run this pragma, which gives me a more, this is actually looking against the SQLite database and giving me the metadata back. What are the columns and data around it? Okay, now I'm importing pandas. So here I'm going to bring in SQLite, and in most of these cells I'm excessively importing the cells because the modules, because I like to make sure the cell will run, and sometimes I pop around in my notebook and then I don't have the import statement there, it's up above. So by including them at lower level cells, it kind of makes it easier. I can pop around more easily. But here I'm going to say read SQL query, and I want to just query that table I created in my SQLite connection, SL connection, and I'll just return 4 rows back. Control Enter will just run it without advancing, and you can see, yep, there it is. Pretty cool. And I could change this to however many rows, but that proves the table, the data frame, was actually saved as a table in SQLite. Okay. So let's take a look at another example here. Here I'm going to say I'm going to run the pandas, right? Read SQL query, and I'm going to be selecting category, summing up sales amount, and I'm using the table I extracted before, which is summarized by product. But now I want a higher level aggregation. I want it to be by category, which is kind of nice. I don't have to go through all the rows, but I'm still rolling it up to a higher level. Now notice, I want to show you, if you look above here, you'll notice this 0, 1, 2, 3. It's called an index. Actually, it's added another index on the table. When you do things with pandas, it likes to always, with a data frame, create this sequential identity column, basically. And it's kind of annoying when you don't need it. It's creating a unique identifier. So you can get rid of it when you read a query by using the index column and tell it to use a different column. Then it will get rid of the index. And so you can see here now I just get totals without the index number. So remember that, because you may find it annoying, as I sometimes do, to keep seeing this sequential number displayed. Now I'm going to be, again, running a query. This is the, you can tell, SQL Server Security. I'm pretty much focused on using that. Get DB data. And this time I'm going against, again, the SQL Server database, bring back dim product category information. And you can see it here, just a couple of rows to prove it's there. And now what I want to do is say, okay, one of the things you'll realize is this stuff in here I don't really need. There's a Spanish and French version name, etc. I'm going to focus on English. So what I want to do here is just bring out the product category key, subcategory key, the product name, but I don't really want to say the language. I'll just say name, right, and status. And we saw that, right? I can run this. Now, and that shows I can get that. Now, one of the problems is I not only have this is just for the product, but I also have all these other tables. I've got subcategory, product category. It seems to me it would be nice if I could just put the product stuff into one table and not have to keep joining 3 different tables. It's kind of annoying. So I'm going to do that by creating a query here that joins all the tables. And all I really want is the keys to get to these tables so I can join back to them. And then I want the English category name, and I'm just going to call it category. English subcategory name, which I'll call subcategory. And the model name as just model. That's all I need. So I'm going to do all these joins and do all the work ahead of time. Run that code, and now that it's stored in SQL, I can run it here, and you'll see that this is not a lot of data. It's just a few columns. Now that I've got that, I'm going to do the same thing I did before. I'm going to run the SQL. Now I'm taking a shortcut here, so I'm going to run this again, generate this product table you see above, but I'm going to say to SQL and create a local table within my SQLite database. If it's already there, just replace it. So again, I wanted to point this out. I had it commented here, but your options when you say if exists, you can replace. You can append, which is really useful if you have like a daily load and you're just adding new rows. Or you can say fail. It should only load once and don't wipe it out if it's there. So those are options. But let me run this. And now I can select from this to see did it work. And again, and this time I'm querying directly against the SQLite database, and there you can see it. So it's all good to go. Okay, so here we're going to be running get DB data, and I just want to select one row from Factor Internet Sales just to see what it looks like. I always like to get a feel of what data looks like before I try something. I don't want to find out I've got a zillion columns when I'm pulling something back. So now that I've kind of taken a look, I'm going to select all the columns from factor into net sales. I'm just going to span this over a row. This allows me to span this command over a row. And I'm going to persist it here. So again, I don't have to keep storing it into data frames. In this case, I can actually take it. Since my getDB data returns a data frame, I can actually just take that and chain onto it to SQL and write it directly into my database. So in this one statement, I've just grabbed data down and pushed it into my SQLite database. And now, wow, I can query it. So if you're noticing a pattern here, I'm going to do the same thing now with dim customer. And I'm going to do it here. And what I've got now is I've got dim customer, dim product as a consolidated set of tables, just all three together. And I've got factor into net sales. So I've got a lot of cool stuff I can do. Now here's where I want to try to show you the real value of doing this. I need to do a lot of work. Now I could create a table out of these tables that are local, but now they've got these local dimension fact tables. I'm going to create a view in SQLite. And I'm going to say if not exists, because if it already exists, then it won't create it. But if it doesn't exist, it creates it. That makes this code rerunnable. Otherwise, if I run this notebook in the future, it would fail, right? But all it is a select statement. I'm joining factor into net sales with customer, with product, and date. Now I'm using all inner joins. I could do a left join. I can do a left outer join. There is no right outer join, so just be aware of that. So the inner join and left joins and left outer joins work, but the rest don't. So that part is a bit of a limitation, but I never use right joins anyway. I tend to think left to right, so I don't do that. But this is what we're doing. Now let's take a closer look at some of this. One of the things I want this view to do is make the columns kind of more usable. What do I mean by that? Well, instead of salary, instead of yearly income, I want to simplify that. I'm going to call it salary. I also want to do, they have number of children at home. Well, I don't really need to know how many. I just want to know do they or not. So I'm doing a case statement, and I say if it's greater than 0, then this column's going to be Y, otherwise no, and I'm going to call it has children, right? This stuff, I'm getting rid of the word English before education, commuting distance. Notice I have birth date. A person's birth date to me doesn't seem terribly useful, but it might be useful to know their age. So by using this conversion function, I'm able to subtract and estimate their physical age, and I'll put that in as a column. So the view is going to take care of all this. Now it's a view, so it is munging the data together on the fly when I ask for it. But again, if I just said create table, it would do the same thing. Or I could start as a data frame and all the different, then persist it again. So there's a lot of different ways to do this, but I'm getting rid of all these joins. I'm just making this easy on myself. So let's run that. And now I'm going to do something. Now I am taking this and I want to run it directly in the SQLite database. So I'm not doing stuff up there in SQL Server or Postgres. I'm working right in SQLite. So now that cursor I created earlier, I'm going to execute it here, and it should work. So let's see if that works. And it did. It should work. And I can tell because I called this vSalesInfo. So let me try it out. Notice there's a bit of a delay because it did a lot of work to get the data around, but it brought back 3 rows as I requested. The head statement says just give me 3 rows back. And all this information is now available. I can see my age. Notice the age is there. Pretty cool stuff. So this is where I can start adding value. I can create, salary bands to say, are they higher income, lower income? I could create maybe age bands. I want to say this person's a minor. This person is, retired or senior citizen or whatever levels I want. And that might be important to my sales information or some other demographic. Now, as I promised, I want to be able to load something from a CSV file. So I've got sales territory. Let's assume that's provided to me in a CSV file. And I'm going to go from where I currently am under the data subdirectory and bring this in. This is, again, pandas is really powerful. The read_CSV is designed to read CSV files into data frames. And now I can say, okay, to SQL, persist that as dim sales territory into my SQLite database. And now what I want to do is I'm going to join factor into net sales to sales territory and group by country and region. Sales territory, country, and sales territory region. and voila. Now, this time I'm using read SQL query, and I had been doing that in going against like SQL Server, etc. in our calling object, but I'm passing the SQL here, and this is, you can see the SL connection, that's SQLite. And I don't want to see that index, so I just suppress it using this index column setting. And a very important thing you may hit, when I first ran this, the numbers were coming up under exponential notation, which I really hate. You know, you see something like 0, 0, xe, blah, 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 e0, and it's this exponential, unreadable format that somebody thought was useful. Not sure who. I'm blaming Sheldon Cooper. It sounds like the kind of thing he would like to do. So by just putting this round function, and this is one of the nice things in Python, you can just concatenate functions. The round will actually round the numbers into whatever you tell it, in this case 2 digits, so we can see it. And I sorted this, if you notice, I did an order by the actual sum amount descending, so I can see totals. So I hope you're seeing some value here. Like now I've got the data here, I can do a really easy query that does me, shows me the total sales by country name, so highest to lowest, etc. So this is really gets into the exploratory data analysis. So imagine we have some data that's actually in our Postgres database, all right? DIM customer, say. And imagine it's, in this case, maybe the customer's not our internet sales customers, but retail. So we'll load that into our retail underscore cust underscore PG for Postgres underscore DF using the my PostgreSDB object we created earlier, which points to our Postgres database. We can just pull that data in. Okay, so I had a little bit of a typo there. I had this misnamed as my Postgres database, but I wanted it to be clearer that it's AdventureWorks. So if I run this now, you can see it worked. And now I can use the toSQL to save that data from now this time Postgres into our SQLite database. And just to confirm it's there, this time I'm doing the read SQL from the SQLite connection, and you see it works. So we've now got the customers from Postgres. So we've been able to pull data from SQL Server, from Postgres, and even a CSV file and consolidate it in one place. Finally, maybe we decide we don't need a table like the Internet Sales Summary. We can use the cursor execute again to run commands against the SQLite database. So let's just prove this is really here now. And here I'm going to say drop Internet Sales table. I'm going to get rid of it. So here you can see it worked. And notice the execute just returns a list, which is why I prefer using the pandas method to get a data frame. Here I'm going to say drop it, the table. And if I run this command again, now it says, wait a minute, there's no such table. Now the takeaway I really want to emphasize there is you can do, create indexes, create tables. You can do any kind of commands that are database relevant you want there. Just execute them. Here I'm dropping a table because I don't need it anymore. One good idea too though, when you're done, close your connections. So I close it by just running this cell. That closes the cursor and then closes the connection to the database. Important to do that. Okay. I do want to make a correction here, which I discovered after I did all this. So I'm going to go back, and it's a good lesson actually anyway, which is when I created my SQLite database, although it worked, I actually didn't put the file extension I should have. So let me go back and show you what I mean. So if you hit this yourself, you will know what to do. This really should have been .db. Excuse me, .db. So if I were to do this, let you connect, that would work. Okay, now I've got this connection. So I just wanted to show that because it's not clear what's going on here. When I didn't do this, it did work, but it means that Windows doesn't really know what program to associate with this, and it's a little bit harder to find when I'm using other programs. Okay, so let me go back to the end here, and I'll just make sure everything's closed. And it's complaining a little bit here because the cursor was never open, but I got what I needed closed. So let me show you one other thing before we finish up, which is a nice way to be able to look at your data is using a product which I downloaded, which is free, which is the SQLite Studio. And I have a whole video on that as well. But in SQLite Studio, I can go in here and say add a database, browse. And this is what I meant because this wasn't showing up initially. So by putting the DB, it just makes it a little easier. You can still use it. Just be careful. If you don't put the DB extension, you may not see things show up. If I open it, I can test the connection. It's good. And here it is. And now I can just double click and you can see the tables we created. SQLite Studio is a really good way. I typically will keep something like SQLite Studio open, as well as whatever my source database tools are, like SQL Server Management Studio. Postgres has their own visualizer. It's actually a pretty good browser as well. But you can see here, I can look at the columns. I can do a lot of things here. Okay, so wrapping up, we talked about why you would want to use SQLite as a local data warehouse, and the advantages it has to be able to, as you saw, we did a lot of massaging and cleaning. We looked at the features of SQLite, and we saw it's a lot. It supports a lot of volume, it's performant, and it lets us do a lot of cool stuff. We looked at the local data warehouse architecture, and the idea there is we're pulling data from a lot of different sources and consolidating it into our local SQLite database. And I reviewed my free Python class that you can use to read any SQL database, and got a closer look at that. Finally, I did a riveting end-to-end data warehouse load and EDA, so I hope you found that useful, and hopefully you want to replicate that in your own work. So I want to thank you. Please share, subscribe, like, let people know about my channel, and always put your comments in, and glad to hear from you.